productivity. We truly believe that it's innovations that are happening in materials that have the capacity to really solve problems in these key industry sectors. So what's our recipe? Our recipe is we always start with the problem statement. We don't just go to the technology and then search for a problem to solve. We work and partner with a lot of large corporations that share with us really the key challenges that they're trying to solve, not just today, but what their roadmap looks like, so that we can go out and through our relationships with universities, really find technology that we can bring to solve those problems. So that's what we do next. We really access what we believe are commercially viable materials technology, mostly at the university level. So really, we're talking some academic founders or professors that have a new technology, but from our relationship with large corporations, we know that these technologies have the capacity to solve those problems. And then we collaborate with those large corporates in those early days so that we can really shape the technology to solve that specific problem. We found that large corporations are also a great resource in that when you have just a couple of founders that don't have a lot of access to lab space or resource or direction, they can actually amplify those company resources in the early days and then validate it and potentially serve as its first customer. And then we call ourselves builders. You know, we really believe in company building. We've done it before with material science-based startups. I think someone said it earlier, hardware, manufactured products, it's hard. It's hard to get them scaled and manufactured, and we invest in real, tangible manufactured products. And so we've done it before, and we lend our expertise to really build companies from the ground up. And the reason we can do that is because we're pretty small. We're a 110 assets under management size fund. Today we have a portfolio of 6 companies, and we'll close 2 additional in the next couple of months. And they're all very disruptive, broad platform technologies that impact all those areas that I described before. And they're from across the country. I think Pete mentioned, you know, innovation is not just happening in Silicon Valley. We believe that too, especially when it comes to manufacturing and scaling up hardware technologies. You know, we are actually partnering with universities and companies across the country, and I think what's happening here in Cincinnati is so exciting. And we really aim to partner with companies and technologies in this area as well. And we have a broad network of partnerships and affiliations with universities where we source our technology, with government agencies who help, you know, be those first development partners with non-dilutive funding in the early days, and then large corporations who can serve as really those early partners for companies to help shape them and potentially be the first customers. And we have a great and diverse LP base that includes Cintrifuse. Really, it's made up of fund-to-funds, family offices, foundations, and university endowments. And our team, you know, is a team of material science and company building experts. So one of the things I wanted to mention that I think is interesting is, you know, we've heard from a lot of large corporations that have sustainability initiatives, but increasingly we're starting to see that the investment community is actually really caring about sustainability and impact. And so for the first year, we at Material Impact, we went through a process by B Corporation. We went through their impact assessment process where we assessed ourselves as a fund and we looked at the impact that we're having internally but also with our business model. And we had every one of our portfolio companies go through the process as well. In some cases, we're talking about companies with a team of 3 people. So not your traditional corporation where, you know, a company is thinking about things like sustainability, or even some of the, you know, operational practices that really are best practice. But what I love about going through this assessment is we're starting to measure our impact. And investors, customers are starting to ask those questions when they meet with Material Impact in our companies. And so even if you don't score very high on the first time that you take this assessment, you can imagine it can really serve as a roadmap for you to benchmark your activity as you grow and scale up. So it's really exciting to see small companies starting to care about these things. So let me get into the portfolio. which is the exciting stuff. So, one thing that I think, we discussed this last night at dinner, our portfolio obviously is focused on generating revenue, but the undercurrent across all of these investments is sustainability. And so what I'm starting to realize is sustainability is table stakes. It's almost the cost of doing good business in today's world. So let me start with our first investment. This is a company called Soft Robotics. So the market need that Soft Robotics is really trying to solve is the fact that conventional robots are really bad at picking stuff up. This is why robotic automation up until now has traditionally been reserved for industries like automotive, semiconductor, and electronics, where you have very repeatable product and process over and over again. A robot can pick up the same object all day long. The moment you introduce variability, a robot doesn't know what to do. So replicating the human hand in robotics has been a real challenge for a lot of large, meaningful markets. So Dr. George Whitesides is at Harvard. He's probably the most cited chemist in the world, and he actually developed a new class of soft robotic grippers that are built of smart materials that can actually pick up items with the same dexterity as the human hand. And what's exciting about this technology is that it does not require the traditional robotic toolkit of sophisticated vision systems and sensors and numerical computation and training. Really, the materials are doing all the work, and that's really the innovation that's exciting. So you can imagine in industries like food and beverage, advanced manufacturing, e-commerce, and retail, where you have a tremendous amount of variability in these products, right? In food, no two apples are even alike. And so today, all of these, picking applications and order fulfillment applications have been done by human beings. And the issue is we just don't have enough people to do these jobs. I think the average age of someone working in manufacturing is 46. We have an aging workforce, people who don't want to go into these jobs, and there's very high turnover because we call some of these jobs like the dull, the dirty, and the dangerous. So Domino's Pizza, for instance, is a customer of Soft Robotics. You may have seen a recent Wall Street Journal article where they're talking about they're implementing robotic automation all the way up until the retail experience. What we do for them at Soft Robotics is we actually automate the packing of their fresh dough. So Domino's ships fresh dough out to all their retail locations, and up until now, it's been people in these big suits in freezers packing fresh dough balls, picking them off the line and packing them into a box. And they had tons of temp agencies on retainer trying to be able to fulfill those jobs because no one really wants that job. We were able to come in and automate that application, which is very exciting. So when I think about robotics, I actually think robotics is truly a sustainability initiative because you want to be able to guarantee that you can get your product out to the people who need it, and you can get it out in a way where you're ensuring that the quality is there and viable. So this is automation to meet increased market demand. We know there's increased market demand for fresh produce. We know there's increased demand for e-commerce and retail goods, but we have this declining labor pool. So how can we ensure that product gets to market? And we heard a lot today from Lisa and Kroger about reducing waste in the food supply chain. One of the top reasons that there is waste in the food supply chain, especially in manufacturing, just has to do with human error, product dropping to the floor, product getting ruined. So ensuring that a robotic gripping system can actually maintain the integrity of the product and get it out safely is a big deal. Also, all of the technology meets FDA food safety requirements. So when you think about bacteria, and pathogens making their way into the food supply chain, that's always by human beings. So if we can remove that element, we can ensure the safety and the viability of that product and getting it to market. So I have a little video here. Oh, good, let's see. You know how to play this? Oh, it's on a separate thing, okay. Sorry about that. Just so you can see it in action. guys some of the applications here. So these are obviously cherry tomatoes coming down the line, and this is at speed. So if you think about increasing efficiency and getting product out to market and increasing your throughput, this is something that soft robotics does very well. Air packaging. Again, I had no idea that all of these applications were done by hand up until this point. Here's the fresh dough ball Domino's application that I mentioned. So, your stoplight peppers. So, those are just some examples so you can see the technology in action. We can go back to the presentation. So, the next company I want to talk about is a company called Infinite Cooling. So, power plants are the largest consumers of water in the US, and most of that water is used for cooling, and most of that water comes from municipal sources and is very expensive. So this is a company that is commercializing a technology out of MIT that uses electric fields to capture the water that's being emitted from factory plumes and recycle it so that it can be reused again and again. And as I'm sure you can imagine, beyond just power plants, anywhere where cooling takes place, whether it's data centers, food production, oil refining and chemicals, universities and hospitals. This is exciting as we think about water scarcity becoming a bigger and bigger issue. So for a single plant, this technology enables 20 to 30% reduction in total plant water consumption, saves 130 million gallons of water, over $1 million of water cost savings a year, and 100% plume elimination, which I think when I would drive down the highway and I see these power plants, I've always assumed that that's smoke coming out, and it's actually water vapor. So this is a big deal to a lot of companies who want to have that completely reduced as well. So we talked a little bit about food and water, and now I want to talk about industrial productivity and the circular economy. So this is a company, Fusion Coolant Systems. They are commercializing a technology out of the University of Michigan. So the market need here was that conventional water and oil-based metal cutting fluids and coolants are inefficient, costly, and environmentally unfriendly. So what Professor Dr. Steven Skerlos at the University of Michigan, who's actually the director of sustainability for the university, created a cooling technology that leverages supercritical CO2 to cut metal faster, cheaper, and cleaner than existing emulsions. So you can imagine there are applications for this anywhere metal is cut. Aerospace, biomedical, and automotive have been really the early adopters of the technology. And what's exciting about this is traditional coolants, I had no idea that anytime metal is cut, you need that constant stream of cooling on both the tool and the metal that's being cut. And what happens with the existing emulsions is that it produces this, if anyone's been on a factory floor and seen this, it produces almost this milk that gets on everything and it gets everywhere. And when workers breathe this in, it causes a tremendous amount of respiratory conditions and complications, and also dermatitis. So beyond promoting a healthy work environment, this technology is completely clean and uses zero water in the solution as well. But beyond that, it also produces clean, dry scrap metal. And what's exciting about that is that dry scrap metal is a much more viable and valuable resource in the circular economy, where it can be recycled to make other advanced materials. So it eliminates post-machine cleaning steps and eliminates all the water that's used to do that as well, with a very minimal environmental impact. So beyond just being a better cutting fluid, the worker health and safety and environmental implications of this technology are huge. So the next company I'll talk about, Amiston, is interestingly enough, is taking scrap metal and turning that into high-value advanced material. So traditional manufacturing processes of high-value raw materials are today, decades old, multi-day operations, multi-step operations, batch to batch, and really environmentally unfriendly. So this is a technology out of MIT and UConn that leverages microwave plasma to create high-value materials much faster, cheaper, and cleaner than the existing alternatives. So today, Amistan is developing advanced materials for industries like additive manufacturing, batteries, lighting, and display and ceramics. And this is a sustainable solution because, as I mentioned, they can actually take scrap metal and recycle it to create high-value powders for the 3D printing industry. The fact that this is also single step and really takes minutes versus multi-day, multi-step means they're reducing a lot of energy as well. And there's no wet chemistries involved in this process, so there's no waste byproduct as well. And the last portfolio company is actually here today, Zero Mass Water. They're really on a mission to make water a resource for everybody, an unlimited resource for everyone. So I'm very excited to introduce Colin, who's here from Zero Mass Water, who's going to tell you a bit more about that company. But if you have any questions on any of these companies or on material impact, I will be here. I do not fly back to Boston until later this afternoon, so please come find me. I would love to meet you. So thank you for your time.
Thank you to Cintrifuse and Material Impact for this opportunity. Thank you all today for coming. It's great to be in a room of like-minded forward thinkers and rule breakers. My name is Colin Goddard. I'm with Zero Mass Water. I'm a director of market development. And this is a company that was formed to fundamentally transform the human relationship to water. Because we have massive problems with water. And you see the SDG 6 around clean water and sanitation, a goal for everyone to have access to that by 2030. Most people, when they see this, they think about the developing country application. While there certainly is many needs in that regard, I've spent a lot of my time in the past few months, a couple hours from here, in Martin County, Kentucky, in a place that is living in essentially third world conditions when it comes to their water. I don't know if you've seen news headlines from what they have to drink out of their taps, but it's things like, the place in America where the water tastes like diesel. These are people who have been in the community, have told me they would love to have the water from Flint, Michigan to drink. And so while we think about SDGs and that objective and that goal in terms of the developing country, we have a lot of work to do, even in here. And the story in Martin County is the story that can be told in rural communities across the states, in agricultural communities in Central Valley, California, places like Flint and other major cities that are having significant crisis with getting clean water to people. So why is that? If we think back at the high level, we have been getting our water the same way for centuries. We essentially wait for water to come from the air through snow or rain down into rivers that go through and pulled into big central treatment plants where they get thrown through a filter and some of it, water gets wasted or chemicals get added to it, and then we send it through a series of water mains and sewer lines and service lines to ultimately reach your tap. And we've been doing this since essentially the Roman era. And that massively long supply chain leaves so many opportunities for changing climates to impact the rain that comes down that fill that river in the first place, or the aging infrastructure that puts contamination into the water while it's getting through that distribution system. And so these are challenging our ability to get clean drinking water, and as a result, our human response to it in the short term has been to drink something out of a single-use plastic bottle, which only further creates negative externalities around the production of that plastic, the transportation of that bulk water, and eventually the waste and the discarding into the local environment. So these are the problems that drive us forward towards our goal of perfect water for every person in every place. And we are now realizing that vision and achieving that goal through what's called a hydro panel. So this is an entirely self-powered, clean energy powered technology that literally creates drinking water out of moisture in the air using nothing but sun and air. Again, it's self-contained, so this is not plugged in anywhere. You're not connecting to water systems. This is not a technology that treats dirty water. This literally makes new clean water out of the air using nothing but the power of the sun, not extracting anything from local resources or reserves. And not only do when you make water in this way, we also mineralize it to improve the taste and can deliver it anywhere it needs to be drank. So we can leapfrog that entire long chain that I mentioned about how we get our water and literally make water at the point of consumption where it needs to be nearly anywhere on the planet. A little bit more of the secret sauce of how that happens. 2 big steps. One is using solar-powered fans. We pull in ambient air around the panels onto a super absorbent proprietary hydroscopic material, very clever application of material science, that naturally absorbs moisture from the air. We then heat that air using solar thermal power to a high temperature to create that temperature differential internally that condenses water out of the material. And at that point, what we have is clean distilled water. I mean, distillation and condensation is some of the most effective ways to create clean drinking water. And so at that point, we then add calcium and magnesium to improve the pH balance of the water, make it slightly alkaline, the mineral content, etc. And then we have our onboard sterilization system using UV, ozone, and a number of other processes to make sure the clean water that we make stays clean before it gets drank. And all of the activity that goes on here is monitored by a number of sensors throughout the process that can relay this information to our network operations center in near real time. So this technology is a solution, it can be applied at a very local level to the most simplest deployment of 2 hydro panels at a home to cover all the drinking water for a family of 4 every single day for 15 years, to those 2 panels scaling up to 10 panels or 15 or 50 panels on a roof to supply a water fountain to a building, or like what we've done in Martin County is our first project in Kentucky, to a local food bank to help food and water insecure families provide that on-site source of water, clean water generation for them that they're putting into jugs and then distributing to the families that come routinely in a package that they can bring back every time and kind of create that circular model to deliver water to those in most need. And simultaneous to that, we are now building the first ever renewable water farms on the planet. So think about massive size solar farms, but with hydro panels that make water instead of electricity to meet the needs of any population that's in crisis and can't have something to drink, or to be very cleverly packaged into something, a sustainable package, locally sourced, and released as a new type of premium sustainable bottled water that is non-extractive again to local resources and a way more sustainable than many other alternatives out there. And a small note to that, there was some conversation earlier about distributed generation and power purchase agreements. We're able to follow that same model, and instead of buying a field of hydro panels, we can set up a water purchase agreement where instead users and customers agree to buy the water at a set cents per gallon over a contracted period of time, just like you would buying electricity instead of the solar panels themselves. Really interesting applications where you can be flexible with financing in that regard. Again, all of our panels are also smart panels. They relay information in real time to our network operations center so we can understand what's going on internally, how much water is being made, what's being produced and stored. And when the panel is deployed in that environment, it has its own internal machine learning algorithms to understand the humidity, the sunlight, all the environmental conditions to optimize water production for that specific location. And so we have visibility now into the quality of the water that's being produced, and also end users through an app can also see for the first time that what they're drinking and putting inside their bodies is clean, which is another level of insight into digital water, so to speak, that is more difficult to get from traditional sources. So this deck was refreshed 2 weeks ago and it's already out of date. We just installed first panels in Scotland, and now we're in 26 countries around the world, several thousand panels of arrays of a variety of sizes, in everywhere from dense jungles to dry arid deserts to major urban centers. And one of the brilliant components of this technology is that the water that's being made on a rooftop in New Delhi in India is the exact same quality and taste and consistency of what's being made in the Sierra Nevada foothills or what's being made in Martin County. Great tasting. Oh, I forgot to mention the water tastes really great. Nice mineral water, alkaline, soft, and again, consistent throughout the whole planet. So what does this mean? This means that with a type of technology like this, you can literally own your own means of water production, own your own sustainability and resiliency, that when systems fail, get overrun, get flooded, and go down, that you have your own separate supply of clean drinking water, that businesses, schools can be ensured that the water they're providing to their staff, their students, is clean, is separate from the other infrastructure that might be more challenged or might be dealing with environmental conditions that make it difficult. So this means that we can fundamentally transform how we get water and how we can provide water to the most needy individuals on the planet, and be really creative about how we can help support businesses looking for more sustainable, more cost-effective ways to create water and create opportunity. So together, we can help make clean water an unlimited resource. Thank you.